So, in this second task of Titanic classification, we make a system which tells whether the person will be safe from sinking, uh, what factors were most likely to lead to the success. Socioeconomic status, age, gender, or other factors. So, through logistic regression, using Python. Now, logistic regression is a supervised machine learning algorithm that can be used to predict the probability of binary outcome. So, it could be whether the people survived or did not survive. So, it's a yes or no. It is based on logistic function which maps any real value to a value between 0 and 1. So logistic regression can handle both continuous and discrete predictor variables and can also model the effect of interactions among them. So logistic regression is widely used in various fields like finance, marketing, healthcare, and social sciences. Applications are predicting whether a customer will buy a product or not based on age, gender, income, etc. Now here we are using it to predict whether the passenger on that particular cruise ship did they survive or not. Okay, so we have imported all the libraries that we need: pandas, numpy, matplotlib, seaborn, sklearn. Okay, scikit-learn, and then load the data. We have loaded the data set. Okay, and we have named it as df. Now it has 891 rows and 12 columns. Number of rows in the columns, you can see. Printing the first 5 rows of the data frame using dot head, and the last 5 rows using dot tail, and then we have described the data. And using dot describe, we have collected information about the data set. Okay, all of the columns, the count, mean, standard deviation, minimum, maximum, and getting now the information using dot info, the data type, and using. Okay, number of values. Now we are checking if there are any missing values using is null dot sum. So as you can see in the age column, there are 177 values which are missing, and in the cabin 687 values. In the age and the cabin, these are the two columns which have null values, and the total number of null values, the sum of which is shown here. And in embarked, there are two null values. Embarked is another column. Um, okay, now we are going to drop the cabin column from the data frame. Okay, since it is not important in our final analysis, in replacing the missing value in each column with mean value. Okay, so and then finding the mode value of embarked column. So age and embarked we have still kept. We have not removed it from the data set that we are going to analyze, and we have filled the missing values with mean value. Okay, now after this, again we check the number of missing values in each column. It's all zero. And here you would not be able to see the cabin column. So now in total there are 11 columns. Further, we do exploratory data analysis. Okay, some statistical measures we understand about the data. Okay, since we have made some changes to it, and the value counts and survived value counts, number of people, males that survived, people who survived. Okay, number of females who survived, making a bar plot for survived columns. As you can see in the passenger class 1, 2, and 3. Okay, there are in total three passenger class. The class of the passengers we seen here in this particular column. We have visualized the data in class 1, 2 and 3, making histogram for survived column, making a pair plot for the survived column using Seaborn library. Furthermore, we have seen the count plot for the survived column, age versus count. We have taken this and making count plot for the sex column. Blue represents male, orange is used to denote the females, and number of survivors gender wise, as you can see, more survivors, those who are males, including the categorical columns. C now, C for that is where they embarked on Cherbourg, Queenstown, and Southampton. So these are the three places that the people embarked the ship, and there were three socio-economic classes: upper, middle, and lower. So we can see number of males, number of females, in total number of people who embarked on Southampton, number of people who embarked in Cherbourg, number of people who embarked in Queenstown. Okay, here we are converting the categorical column. Male is 1, female is 0, and people who embarked on Southampton, S is 0, C is 1, Q is 3. So converting it into numbers. Okay, so here you can take, you can see that the embarked column from S, Q, and C has changed into 0, 1, and 3, and then the sex column to zeros and ones. Okay, these two columns we have converted from categorical, separating features and target. Okay, we have dropped the passenger ID, this particular column, the name, ticket, and survived. These columns have been dropped. The rest of the columns, they are all numerical columns, have been kept on total 7 columns. Now we have, so X has this particular value, and Y, capital Y, has this particular value, splitting the data into training data and test data using random state as 2, test size as 0.2. We split the data. Now we train the model here using logistic regression. And now we evaluate the model, and the accuracy score on the training data is what we get here, which is 0.804 accuracy of training data, accuracy of test data, as you can see, print, and accuracy of score of test data is 0.776. Thank you. In Titanic classification, now we'll make a system which tells a person will are they safe from sinking or not, and which factors contribute. Okay, so here you're going to use logistic regression. In logistic regression, we are using a supervised machine learning algorithm, wherein we're going to predict the probability of a binary outcome, whether they will survive, yes or no. Okay, so binary classification refers to predicting the output variable that is discrete in two classes. So either they're going to be value 0 or it's going to be 1. Okay, there could be no other value. Okay, so logistic regression using this particular regression method, we can predict whether the customer will buy a product based on the age, gender, income. These are the features or the characteristics which influence the outcome um, of the customer, or the decision of the customer to buy that particular product or the service. We can also use it to know whether a person, so basically for predicting certain things, whether patient has certain disease or not based on the symptoms, okay, the test results and the medical history of that particular patient. So, based on all these things, we will get to know a patient has that particular disease or he does not. So, there could be only two outcomes, yes or no. Now, we're going to build a logistic regression model. For that, we're importing the libraries that we need, uh, the basic libraries in Python, which is pandas, numeric Python, matplotlib for the visualization, cborn for the graphs, and the scikit-learn model selection for the train test split, and linear model for the logistic regression. And using the sklearn matrix, we're going to use accuracy score to determine the accuracy of the machine learning model, and simple imputer. So we are going to take the data. I've taken it from Kaggle, is using a CSV file, and upload it to the pandas data frame. So I've stored it in Google Drive. So this is the entire data. It has 891 rows and 12 columns. So the name of the columns that you can see highlighted in bold: passenger ID, survived, passenger class. Now there are three class of passengers, one, two, and three. The name of the passengers, their gender, age, the spouse that they would be having, the part, ticket number, the fare, the cabin number that they have been allotted, and where they embarked, which port did they uh, embark the ship. So now we're going to see the number of rows in column using dot shape. Using dot at the first five rows of the data frames we have retrieved from the data set, and using dot till very last five rows of the data set, and then using dot describe, you're getting to know about the statistical measures information about with the columns that have numbers in them. Okay, that have integers and numerical columns. Only their statistical measures have been seen. So in total there are seven columns. Their count, the mean, the standard deviation, minimum, maximum value of the passenger ID, survived. In survived, it either could be 0 or 1. So in passenger class, then the age of the people, and the fare amount that they have paid to purchase that particular ticket, and the spouse and sibling spouse what that they have embarked the ship with, in the percentage 25, 50, 75. Now we're getting some further information. We are doing exploratory data analysis here. We're trying to get more information about the data set using dot info, wherein we can see that passenger ID column has 891 values which are not null. Not null values meaning they have a certain value. It is there, okay, present in the data set. It is int 64 bits. Okay, and name, as you can see, name, then sex, and then embarked. These are the three columns wherein you would see and ticket. Okay, ticket ID. These are the four columns where you will see that it's an object type. Okay, wherein there are alphabets and not just numbers presented. The rest of them have int, and age is float because there is there's no decimal value in each. The rest of them have certain decimal values. Okay, so you could say here not null. So you can see that cabin has a lot of null values. Age also has, and embarked also has two null values. Null value meaning values are not present there. Okay, so as you can see, the data types of each of these columns, int 64 we have 5 columns, object we have 5, and float 64 we have 2. So here we can see we are dropping the NA values. There is not available values. When we drop, we get this particular 183 rows and 12 columns, because those many rows wherein any of the columns does not have values, we have omitted it. Now this check the number of missing values. Now we are going to understand how many values have been missing in our data set. So here we can see in age 177 values are missing, in cabin 687, and marked there are two values which are missing. Again, age is another important criteria because you're going to do survival analysis. Okay, with this particular each row actually is a passenger. Okay, it's a passenger ID, whether they have survived or not. So it is mainly going to be based on age and their gender, and whether uh, their class, socioeconomic class, so the fare and the uh, ticket, the passenger class that they belong to. So these are the few important columns that we are going to consider here. So handling the missing values. Now, what are you going to do about these values which are missing? First of all, the cabin column, which is very irrelevant to because it does not have much influence over whether the passenger survived the Titanic incident or not. So we're going to drop it entirely. Now, axis one meaning in the from the column. Okay, the axis zero represents the rows, and one meaning the column. We are omitting the entire cabin column here. So now we're going to have 11 columns, not 12, and we replace the values and age. Now, age is a column that we want to keep. Okay, because we're going to use it further in the logistic regression model. So I'm gonna fill all those values of age with mean value of the age. Okay, mean value of the all the passenger ages, and we're gonna fill the embarked value with mode. The most mode is the most recurring number. Okay, here it is embarked. There are three ports that the passengers embarked on the Titanic. Uh, Mainly, there is Sherbrooke, which is represented by C, capital C, Queenstown, which is represented by Q, and Southampton, which is represented by S. So the most repeated value is S. So the most number of passengers have aboard the ship from Southampton port. So the mode would be S, and the missing two embarked values that are there in our data set would be given S. Has the two missing values of the two passengers that we do not know where they embarked from, the port that they embarked from. So here we can see, after filling in all the null values and dropping the cabin column, we get 11 columns, and there are zero null values. There's zero missing values now in each of these columns. Now we're going to do some data analysis further of the new data set that we have created. So here we can see the number of people that have survived. Now finding number of people survived and not survived. So this is a disaster event. Zero meaning number of people that did not survive, and one meaning number of people survived. Okay, so zero denotes people who did not survive, and one those who survived. So majority of people, in total 549 of them did not survive, and out of total number of passengers, okay, and 342 of them survived. Now we're going to visualize the data. So before fitting the model, before doing all that, we want to visualize the data. Here we are going to make a bar plot, okay, for the survived column. Age versus the passenger class, the ticket that they had purchased. First, second, and third, the three classes. And on x-axis we have kept the passenger class. On y-axis we have kept the age. And using the Seaborn for graph and matplotlib for visualization, you can see it's color coded. So the people, maximum people, those who survive according to the age and the class. uh, so they were of the first class ticket that they had. These passengers up to the age of 32 or 33, they survived, majority of them, making histograms of survived columns. So this is on x-axis survived, y-axis is count. Then here you can see the count plot for survived column. Survived the gender wise. Zero are the males and one are the females, according to the age versus count. And we are going to use a pair plot. So each of these values where we have in the columns, versus passenger ID versus fare, survived versus fare, P class, passenger class, and fare, and then all these values that we have taken. So the passenger class is a proxy for socio-economic status. Okay, and as you can see, the males that survived 577, because of the high number of males, and then the 314 females which had embarked the Titanic ship. S, that is people that boarded on Southampton port, is 644. The majority of them boarded on Southampton port, embarked, and on the Cherbourg port there were 168, and Queenstown port there were 77 passengers. And you're going to replace, now you convert the categorical column into numerical. Male is to denote 0 and female is 1. So now we are encoding S, C, and Q of the embarked column we are denoting it as 0, 1, and 2. As you can see, the topmost five rows, afterwards the change in the embarked, and the gender, the sex column. We can also now separate the features and targets. So a machine learning model should be able to tell whether passengers survive based on the features. So we only keep the relevant features that have influenced the chances of survival. So when we drop the passenger ID, name, ticket, and survive, these four columns, okay, that is the axis one, okay, that we have mentioned. We encoded to capital X, and for Y we use the survived column. So only the relevant columns we have kept, and on y-axis the survived column. And here we can see we are splitting the data into training and test data set. So 0.2, that is 20% of the data set we have kept it as a test. The test size is 20%, and the train would be 80%. So 80 to 20 ratio we have kept it. Then this is what we are seeing. X, these are the arrays. X underscore train, X underscore test, Y underscore train, Y underscore test, and then splitting the data. And you're using the training the model using logistic regression. Okay, so model, we're fitting the model here, and now we're going to evaluate accuracy score. We're going to predict. Okay, using the sklearn library, we are using in predicting the x underscore train underscore prediction, and accuracy score of the training data that we have trained is 0.8. Now, accuracy of the training data we got to know now of the testing data. So print the test underscore prediction, then test data accuracy, and the accuracy score of the test data is 0.7. Okay, so the accuracy score of the test data is 0.7, and accuracy score of the train data is 0.8. Thank you.